Good morning, good afternoon, good evening to everybody joining from across the globe on this webinar, Navigating Emerging Trends in the Database Technologies. Uh, so, thank you so much for dialing in on this Wednesday afternoon. Let me share my screen and then we can dive into the content. Just allow me 1 minute. Okay, so a little bit about myself. I'm Jagdish Rao. I'm currently working as a senior technical account manager with YugabyteDB. I am currently handling a couple of accounts in the telecom, the business and financial services industries in a multi-million dollar deal size. Prior to Yugabyte, I was working with different organizations. I've worked with a few of the leading cloud providers and hyperscalers like Microsoft, AWS, and VMware as well. And in my career, primarily, I've worked as a support engineer. I've worked as an architect, and I've worked as a consultant delivering solutions in the digital workspace. Technology uh, in a little over a decade of experience. And in my leisure time, I basically love to travel a lot. I tend to keep myself updated with the latest technical buzz of the industry. And I'm a very avid fictional book reader. I like to read as and when I get time. So that's pretty much about me. Let's quickly dive into the contents of for today's session. Now, the objective for today's session is basically to take you through the database evolutions over the years on what the world started off with and how the current database technologies is heading towards with. Will determine the current trends in app and the infrastructure layers and why there was a need to determine a data layer modernization. Why was the need, or what is the crux behind our data layer modernization efforts? We look into the trade-offs for different database types that is currently serving out there in market for different use cases out there. Will determine the database landscapes and what is the current focus of the future trends and technologies. And we'll take a jibe and a deep dive, on a high level that how Yugabyte, that is us, we are kind of, fixing the things and how the distributed SQL in together in the database is actually a game changer, and how it can benefit your use cases out there. And at the end of the session, there would be a small walkthrough or a demo of how Yugabyte is actually in action. So without further ado, let's quickly jump into why actually there was a need for a data layer modernization. Now, probably you might have seen this slide, with these kind of trends over 1,000 number of times with different vendors, focusing more on microservices, focusing more on infrastructure layer, focusing more on application modernization, moving from a monolithic to a microservices kind of an architecture. But the shift to uh, application or infrastructure is not just the bug doesn't stop right at the application or infrastructure layer. Now, if you have an ideology of modernizing your application or infrastructure, but you need to also look into the data layer modernization as well. But without without the data layer modernization, absolutely application and infrastructure layer cannot fulfill your use cases with the future uh, with the future demands of, or with the over changing demands of your global user base. Now, as a result of these demands, that have come down from our customers or organizations who are kind of utilizing these modern age modern age technologies, or as their use cases are kind of growing, the need for data layer modernization came into persistence. We have seen in kind of the infrastructure layer, we have seen the paradigm shift from bare metal from a bare metal to proprietary physical infrastructure, and towards commodity hardware, and then to the emerging of the cloud. On the application side also, we have seen the tremendous shift from monolithic to microservices, and then to container based architectures, and towards now the trend in the buzzword in the industry is the Kubernetes, right? The world is going gaga over Kubernetes, and everybody's running behind modernizing their application into a more container based approach via the Kubernetes. The more recently we've seen that what is kind of missing is what are the data layer, right? The data layer is what we say the data is the new oil of the future, right? It forms the core foundation of any application. Again, it is very essential for your business to become a more data centric. So going again back to the question, what would be the next for data layer? Now we've seen that, or we have established that, we have always been looking at the wrong picture altogether. Now, if you look at the big picture, we have seen infrastructure layer modernization, we have seen application layer modernizations, but somewhere we do not give the equal amount of importance to the data layer as well, right? Now, to talk about few of the challenges of modern ages, the drivers for looking at or the organizations are looking at the data layer for modernizing is because they need an accelerated time to market, right? They need to deliver a high value applications. Their go to market strategies should be so robust enough or so agile enough that they can speed up their development activities, and they can launch their product to market in no time. Now, having said this, having the driver for an accelerated speed to market, the few roadblocks that these days organizations met is the anti-agile pre-cloud databases which are not sound enough to cater to their needs, their GTM strategies. Now, provisioning, scaling, and upgrades, those are also taking weeks altogether in order to deploy the infrastructure, deploy their application, and then by the time they are ready to go to market, they have lost a considerable amount of time, maybe in matter of months or in matter of years. That is when they keep lagging behind on their schedules. And again, bolt-on resilience is something that organizations feel that it is also a very a strong factor of bringing them down onto their go-to-market strategies. Other thing which organizations currently focus is on reducing the cost, right? Which is basically spend less on technology, or spend less on the traditional licensing cost, and the agnostic to the cloud, basically, right? So basically, customers or the organizations do not want a vendor lock-in. They would want to exit as they like, and they need to spend less on the traditional uh, or proprietary licensing. So the roadblocks that we see usually on this is the licensing is basically very expensive. The database sprawl is huge, so they're kind of confused on which database to go for. And once an organization decides on a particular database that they need to deploy their solution or their use case on, the provisioning time takes a longer period of time to assess, and then to deploy the infrastructure, and then to go live on the market. The last or the most prominent drivers for the data layer modernization that we see is complying with the regulatory authority, whether in Europe it is GDPR, in India for payments card industry we have PCDIS compliance. So compliance is one more reason that organizations fear a lot, and they feel that the solution that they would want to deploy should have a less risk or meeting their compliance and regulatory standards, right? Again, the roadblocks is as organizations build solutions for larger or wider audiences, right? What they do is uh, their user base tends to grow, and the geo distribution of data or the data sovereignty again becomes a huge daunting task for organizations, because the data in most of the countries, like I mentioned, in Europe, we have a GDPR regulations which states that the organization's data should reside within the confinements of their country or of their continent, right? And that becomes a huge headache in terms of management and in terms of catering to their wider or larger or global audiences. Again, there is a cloud and database lock-in. The organizations move from monolithic to cloud native world or a cloud first world, the vendor lock-ins come into picture, wherein organization has to be logged in for X number of years in order to drive the ROI of their investments into the cloud strategies, right? Uh, last but not the all, last but not the all, the other roadblocks that we feel is that, or that predominantly is out there in the market is, it's either given or it's either all or nothing, right? Either you have to commit to a particular database and stick to it for n number of years, or you need to move out from that particular cloud offering or that cloud vendor completely, right? Uh, so let's take a quick look at what are the modern age databases, and how these databases are kind of unable to fix a particular gap. So in kind of the legacy relational kind of databases, although they do provide strong consistency and asset properties, right, and they have like a stronger or consistent indexes, and they do provide a relational data model, but then the trade-offs for those kind of databases, or the gaps that they kind of uh, do not tend to hover as, again, there is a day two operation of manual sharding. Your DBS has to shard the data manually. There's again a bolt-on replication, so you need to define the replication on those databases, and then they lack the feature of geo redundancy or geo distribution, which again puts your thoughts into backtrack, where you cannot meet the uh, cannot meet the demands for your global user base. Again, the world shifted to from relational databases that we saw in the past. The world shifted to a more non-relational kind of a data. The use cases where your OLAP came into existence. The analytical workloads, the data lakes, the analysis on the fly. So those kind of use cases basically came into existence. Wherein the non-relational databases world originated, right? The non-relational databases, again, they gave scalability. They were geo-redundant, and they were catering towards global user base. They had native replication, but then again they failed, to cater to consistency or the asset compliancy of the databases offerings, that came along with the non-relational flow. There were no indexes basically on the non-relational side, and they failed. They only catered to a specific set of OLAP use cases, wherein the relational use cases were not compatible enough for the performance. Again, took a hit on non-relational databases. Then again, the world shifted to the cloud-centric or the cloud-first world, right? The more emergence of cloud databases came into market. Again, the cloud databases came with its own pros and cons. Pros being the ease of use. They were more resilient to, they were more tolerant to attacks, or they were more tolerant to, infrastructure outages. And they were strongly consistent, right? But then the pros also came with cons, like you had to be logged into a particular cloud for X number of years. They were not open source. Again, cloud providers were using the proprietary software, right? And they were kind of limited in terms of scale, and they were offering a very very limited geo distribution or geo resiliency, right? Uh, Having said all of these, like, so Yugabyte, right? What is Yugabyte, and why are we so different, and how are we kind of bridging the gap? Let's answer these kind of questions to set the context or foundation of our discussion, right? So let's say, or let's just answer first, who is Yugabyte, or what is Yugabyte, right? So fast forwarding 6 years back, what we see is, Yugabyte was basically founded 6 years back with the belief that the next data base, or the next decade in the database industry, will see a major change, or a paradigm shift in the system of records, or the enterprise running their business and their digital services would see a tremendous shift in the digital space, in the data space, right? Now we are the company behind the YugabyteDB, which is basically a distributed SQL database. Again, it is built with first and foremost for transactional workloads, for transactional applications, and support wide variety of use cases, right? We are cloud native, we are digital first. So and our open source database is currently available in Apache 2.0 open source license, right? So any user absolutely can go ahead and start using Yugabyte database on the fly. Now we are, like I mentioned, we are kind of an 100% open source database, and we absolutely run on any kind of infrastructure, be it bare metal, be it physical, public clouds. You can run it on your own data centers. You can run it on a hybrid cloud. You can, if you have a multi-cloud strategy, you can absolutely, pick up Yugabyte database and you can start running in it. Now our database is pretty flexible, and we are uh, 100% open source SQL system, 100% distributed SQL database out there in market. Now we are again used by both small and larger, Fortune 500 enterprises, like unlike by retailers, advertisers, financial and services companies, telecoms, and so on and so forth. Now again, coming back to the second question is, what is a Yugabyte and why this name actually, how this uh, how this word was coined, Yugabyte. Now, Yugabyte is basically a play of words. So, Yugami is actually a Sanskrit word which means eternity, right? Or which means extremely long period of time. And byte is again a small unit of data, right? How we define the data in terms of size. So, basically, if you coin both the words together, the crux of the line is data living or data residing forever without limits, right? Which means that, Yugabyte as a database, you can absolutely uh, throw the data in our database and it will reside for ages to come out there. Now again, the database grows, and the data continues to grow. We believe it's not just the quantity of data that is created, but then the reliability of the storage, to store it anywhere and access it from anywhere. So we talked about and we established about what Yugabyte is all about. Now let us take a quick step back and see how Yugabyte is catering to the trade-offs, from the relational, from the non-relational, from the cloud database world that we talked about. So these are a few of the key features that we kind of offer from our product. Like we are 100% Postgres compatible database. We have reused the Postgres query layer, and we are Cassandra. We kind of have two APIs, right, which I'll talk about in the next slide when we talk about the architecture of Yugabyte. But to give a context or to set a context, we are Cassandra API compatible, and we have re-architected YSQL API. So together we are serving two API layers on top, and we offer advanced features, like triggers, stored procedures, partial indexes, securities, and etc. Now, talking about the availability, we are kind of our database is resilient to any infrastructure outages. So we survive multiple major failures, like on a node level, on a zone level, or on a region or a database, a data center level as well, like giving you absolutely zero downtime, and you can upgrade it. You can have upgrades, and you can have security patching with absolutely zero downtime on your database, right? We have a recovery RTO, or recovery time object of 3 seconds, and we have an RPO of recovery point object of 0 seconds as well. For the failover time, it's about 30 to 20 seconds for RDS or Aurora. So we are kind of much faster, than the failover times for RDS and Aurora. Again, on the horizontal scaling, we can scale horizontal. We are strongly consistent in terms of read and writes. And the connection, you can amplify the connections by adding nodes as well to your clusters. Again, adding of additional nodes is pretty quick, and the database scales very fast in terms of as soon as you add nodes. Uh, on the geo distribution as well, we offer geo distribution and geo partitioning capabilities with Yugabyte as well, right? Again, the use cases like your data needs to reside closer to your closer to your users, and the compliance and regulatory requirements can also be met with the help of Yugabyte database, right? Now, just to give you a high-level overview of what Yugabyte is all about in a single slide, right? So at the bottom, like you can see, right, we have a distributed transaction storage layer. Now, this layer is basically inspired by Google Spanner, which is built on horizontal scalability and geo-distribution of applications. The transaction layer is basically responsible, or the storage layer is basically responsible for your transactions, your sharding, your replication, and the data persistence as well, right? Along with the inspiration of Spanner, we took proven technologies like raft consensus algorithm, that we enhanced, and we optimized to build an enterprise class 100% open source SQL database, right? Now, if we move up, right, it's actually a API layer, which is a pluggable query languages, and we offer a Postgres compatible query like Amazon Aurora, which can support a rich set of functionalities, like, and it also supports a broad range of use cases possible. Now we support two flavor of distributed API architectures, like I mentioned. One is the SQL or the relational API layer, which is again Postgres compatible, and the other one is the API layer, which is Cassandra compatible, right? And both are flexible, and both can expand to your use cases as well. And then the YugabyteDB has the ability to run anywhere, right? You can absolutely, like I mentioned, you can absolutely deploy it on any cloud offerings, AWS, GCP. We recently introduced Microsoft Azure as well. You can also deploy it in containerized offerings like Tanzu and Kubernetes, and you can also deploy it in your private or in your private data centers as well. And you can also deploy this in a multi-cloud fashion, or a multi-region, or a multi-cloud fashion as well, like if you have a multi-cloud strategies as a part of your organizational roadmap. We acknowledge that not all customers are same, like our fingers, right? Not all fingers are same. So not all customer use cases, not all customer roadmaps, or not all customer journeys would be same, right? Some of the customers would look at modernizing their database. They would have legacy databases or monolithic databases, and their strategy permits, or their strategy looks like they need to modernize their databases. Whereas on the other hand, some customers are building born in the cloud apps, or they need to be cloud first organizations, and their strategy lies that their application should be agile, and their application should be more cloud first or cloud oriented, right? On the other set of users, they have some niche kind of use cases where they are catering to edge and IoT applications, like data sources are at the edge that would require new data architecture. Now those benefits are useless again if they are sort of rigid and can only be used in a narrow set of cases. Now we recognize again that maybe tired of your legacy solutions in the past decade, and you're kind of looking at database modernization overalls, or you should be looking at the new age or IoT use cases. Now, again, for each of these, the distributed database again enables you to address not just the stage that you are in, but also what is coming next. So not only you are looking at your existing use cases, you're also looking at modernizing your data layer to be ready for your next level of changes, right? So that is when Yugabyte fits in at the right sweet spot, right, for all of your use cases. Having talked about, or having looked into the database trade-offs, how Yugabyte came into existence, how Yugabyte sets apart for all the trade-offs that we discussed about. Now let's take a deep dive at the architecture layer, right? What is so different about, or how we are doing it differently from others, out there in the gamut of all the databases. Now, if you take a look at this, the database is basically, has been taken from Google Spanner. The idea or the inspiration was taken from Google Spanner, and YugabyteDB basically brought the ideas into open source database form, right? And one compatible with existing databases are like the Postgres and Cassandra. On the top, you can see, or on the bottom, you can see the DocDB layer, basically Yugabyte's distributed document store, right? Which is common across both the APIs. And it is based on the RocksDB storage engine. Our DocDB is basically raft replication is, the Raft replication is one of the features. It is integrated in the document DB as well. The document store is ACID compliant, meaning which it is strongly consistent. You can maintain the same level of isolations and the atomicity of the data going inside the docs DB, right? Again, sharding, replication, fault tolerant, ACID transaction architectures all comes, out of the box from the Yugabyte offering as well. Like on the top, you can see there are two query layers, right? The Cassandra compatible query and the SQL compatible query. The SQL compatible query is a fully relational SQL API that you can use for your relational data workloads, and it is wire compatible with SQL language, in PostgreSQL. On the Cassandra, you can have, the roots in Cassandra query language. So both of these API layers are again out of the box, and you can utilize it from the day one itself. All right. So again, YugabyteDB, you can deploy it in a private or a public cloud. You can deploy it in a hybrid cloud, right? Now this is consistent across all the regions, right? Or on the AZs or on the racks on your database, where your database currently exists. And with this architecture, with the distributed architecture, this can sustain one region failure. For instance, if your region completely goes down, right? For example, let's say you have deployed this Yugabyte database in your private or a public cloud with replication factor of 3, meaning which you have kind of 3 copies of your database residing, right? So what would happen is Yugabyte database has an automatic sharding, which means that your tables are basically sharded and none of a single availability zone or a particular node will have all of your shards, right? Your shards will basically be spread across all of the availability zones, right? In case of, let's say, this particular region, like your region 3 goes down, again, your database can sustain because your shards would be residing, or your table shards will be residing in both of your zones, right? In AZ1 and AZ2, your complete database table will be residing. So what that would happen is, your in case of a complete region failure going down, also your database can be catering down to users, request, read or write request as well, right? The consistency again will be restored in case of catastrophic failures as well. You could also deploy this in case of a hybrid cloud as well. Now, in case of a complete cloud region going down, again, your database will be serving read and write requests. And in case of an hybrid cloud, also, you can tolerate up to 2 rack failures or a 1 data center completely going down. So again, Yugabyte DB allows consistent replication across all of your availability zones, or even data centers, maintaining fault tolerance. And this kind of architecture, the distributed architecture, guarantees you scalability, resiliency, geo-partition, and geo-distribution features, right? Again, these are few of the few of the architectures or best practice that we suggest, or these are few of the architecture types that you can deploy Yugabyte with. So either you can deploy it in a single region or a multi-zone kind of a fashion. If you are inclined towards one public cloud, you can deploy it in multi-region. If you want more high availability, more resiliency, right? Where you can have consistency across regions with an auto region failover or a repair, right? And if your organization supports a multi-cloud or a multi-region strategy, right? So you can deploy it in multi-cloud. Again, with a multi-cloud strategy, what you would be achieving it is a consistency across multiple clouds. You can also enable auto cloud level failover or database repair activity as well. And with this strategy, again, we have geo distribution with sync replication, right, where your data sovereignty is maintained. And if you talk about the compliance or regulatory aspects in few industries, if your organization or if your use cases are required to comply with certain standards, certain industry standards, where data residency and data sovereignty is required. So with the help of geo-distributed architecture, you can maintain stickiness, the data stickiness closer to your user base. Again, over the years, what we have seen is, a traditional stack architecture is where a monolithic application will be there. There will be a set of user, and the database is basically catering to a particular uh, set of region, right? Uh, Again, the paradigm shifted towards microservices, wherein the monolithic databases were broken down into microservices, and it was more faster. But then again, it was limited to a particular region, right? Again, there was a paradigm shift towards microservices in a multi-region fashion, wherein there was absolutely no replication between both the databases, and again, it was solely catering to a particular user or a particular region, right? Now, with the help of Yugabyte, what we have achieved, or what we have kind of bridged the gap, is basically irrespective of microservices, irrespective of the deployment methods, irrespective of the type, or irrespective of the architecture that you would be deploying. You can scale out your applications in multiple geographies with the help of distributed SQL. And you can also maintain the resiliency, the same level of consistency, the same level of asset properties that you would be maintaining with the other databases out there in market. With the help of Yugabyte, again, as you can see, the tables are sharded across the nodes, and the help of the distributed architecture, the geo distribution is again catered to your user base. And we also have row level partitioning, which will pin the rows of a particular table or index to a specific geography, right? With this also, we maintain strong sets of consistency, and we also maintain low read and write latency, with the help of row level geopartitioning. Uh, Now, let us take a quick dive at how, or what are the offerings Yugabyte has in store, in order for moving your journey, or proceeding your journey, from monolithic or a different SQL, or a uh, or a relational database to distributed SQL, with our offering. So we have a offering YugabyteDB Voyager, right? What basically would do is, now if you are residing on cloud or on-prem on any of the Postgres SQL, databases, or proprietary Oracle or MySQL databases, or cloud offering like Amazon Aurora or RDS, right, or other public cloud vendors, like if you have Azure SQL, or Google Cloud Spanner, or if you're using Google Cloud SQL, you can actually use the Yugabyte DB Voyager application to move into Yugabyte database. With the migration steps are identical for all sources. The source remains the same, and the target remains the same. The migration steps too, there is no changes absolutely on the migration steps, irrespective if you are using Postgres or if you are using Azure SQL or Amazon RDS. The current version supports an offline migration as well, right? And online migration is actually planned, which is offline, and CDC is actually planned in near future. So as and when new iterations of the Voyager comes in, as a part of roadmap, the online migration can be seen as a part of Voyager feature going forward. All right. So we have talked about a lot about the trade-offs, the modern age needs to migrate to the new sets of emerging trends in the database market, towards the distributed SQL, how Yugabyte came into picture, how Yugabyte is filling the gap, where other database vendors or other database offerings in market fail to bridge the gap. Uh, we took a look at the high-level architecture of the Yugabyte, and what are the few features that stands Yugabyte apart out there in market. Now let's take a quick look at how Yugabyte is actually helping, or what kind of use cases Yugabyte is currently offering out there in market, and what are the some of the use cases. Let's take a dive at look at the use cases on how Yugabyte is filling in the gap. Now, where is the distributed SQL used in market today, right? The common transactional databases or the architecture patterns we see across in our engagement with customers, or the existing customers that we have, association with us is, on the streaming and event data. So again, there are some media houses, and some content organizations which are catering to the OTT content in few geographies. They are using Yugabyte database as of today. Again, we are serving the analytics and the data factory use cases as well. The metadata and the entitlement profiling. We are also catering to such kind of customer use cases. Catalogs and systems of records. This is where we have seen a tremendous shift in the data modernization efforts. We have uh, good retail customers, globally, who are using Yugabyte as well. Again, in fact, as a matter of fact, we are powering some of the world largest retailers' global catalogs uh, with the help of Yugabyte database, right? Uh, for geo redundant or geo distributed data, we are catering to those kind of use cases and customers as well. And machine learning features as well. There are few customers who have few machine learning use cases. We are also catering to their use cases, right? So these are few of the these are not the these are just a subset of the use cases, and then there are many more applications of distributed SQL that we have seen. Organizations, Fortune 500 global entities, partnering with Yugabyte and collaborating with us in their modernization and application modernization journeys, right? Uh, for today's webinar, I would like to highlight the top 4 use cases, how Yugabyte had a tremendous impact on their use cases and their modernization efforts, right? So these are the 4 top Yugabyte use cases. I'll talk about a use case from a geo distributed application space where a retail customer, how Yugabyte helped a retail customer in modernizing and powering their catalog, with millions and millions of items listed on their catalogs, and how we were able to mitigate a huge uh, region outage without the need for without the need for the customer switching back to their failover DR sites, right? I'll talk about a use case where we were able to modernize the application and database for a customer, and how they were able to achieve uh, their their strategy for modernizing their data layer completely. A very interesting use case I would talk about is an IoT and edge, like how we are powering a customer, on the IoT and edge, and how they were able to, utilize Yugabyte to the maximum potential. And last but not the least, how we were able to, modernize a mission critical microservice for a customer of ours. So on the geo distributor application, like we have a retail customer, who's offering millions of products and selling uh, thousands of products day in and day out, operating on a huge scale, right? When I say huge scale, they are kind of the largest retail customers globally, and we are powering their catalog, which has a little over 1 million items in their catalog, right? Now, talking about their application landscape, so they were utilizing or they were kind of cloud native. They had a cloud native stack which were based on Apache Kafka, uh, uh, and they were Apache Cassandra they were using Apache Cassandra database, right? Now the technology team that builds and runs the platform for this particular customer approached Yugabyte with their problem. The major pain point was the consistency in their product catalog, right? The original Apache Cassandra solution that they were using led to data inconsistencies. Again, they evaluated many solutions out there, but then they were not quite happy. Again, they selected YugabyteDB for its asset compliance transaction capabilities, with a strong consistency in a multi-region deployment. The multi-API approach helped them, to uh, achieve this shortfall that they were experiencing with an Apache Cassandra database, right? Uh, as a result of deploying Yugabyte in a multi-region fashion, the retailer eliminated the buyer or seller friction in their product catalog. They eliminated the cost, which was a big driving factor for them, and their engineering ability improved to deliver better solutions. The day-to jobs of their engineering, where they had to sit down and fix their databases, non-consistency in their databases, the day-to jobs were actually reduced, and now their engineering efforts could be solely focused on building the new edge platform and new edge compatible, new age applications for the engineering teams of the customer. And if we talk about the numbers for this customer, right, we were able to achieve a linear throughput of about 250,000 queries per second, with a billion of key mappings for their catalogs, right? And now, with the help of Yugabyte, they were more open source. They were cloud agnostic. They had a just geo-distributed architecture, right? They were multi-row ACID compliant. They had alternate key lookup as well, and in fact, they were able to handle the Black Friday and Cyber Monday peak events. And during the same event, one of their availability zones in their cloud vendor actually went down, and because of this geo-distributed database, with the two regions absolutely functioning, they were able to, go past the peak events like the Cyber Monday and Black Friday without any downtime to their cataloging website. Talking about the on the IoT and use case, we have a manufacturing or automotive customer, right? How we are kind of powering them as or let me talk about a use case for one of our telecom giants, that we are partnering with, to push the envelope of self-organizing networks by, combining multiple data sources. Now, this customer, after extensive testing and evaluation of a lot of options, came to Yugabyte, and they selected us as a strategic data layer for their choice, right? They were kind of moving away from MySQL, and they were uh, kind of utilizing other NoSQL databases that were synchronously kind of replicating data across multiple regions and three data centers. Now, Yugabyte again was a weapon of choice, and we were able to move their monolithic database to more microservice-based approach, where they were able to containerize their database offering completely, right, in Kubernetes. And Yugabyte's database currently supports a little over 700 terabytes of data, and the data is growing in massive size, and we tend to hit a 3 petabyte data scale by the end of this year, thanks to the multi API interface, that is preparing or that is helping the customer to support the YSQL workloads as well, right? Um, on the database modernization efforts, right, we enabled a financial customer to quickly and easily expose and decouple a data retrieval of key online transaction workloads to a cloud, enabled microservices architecture, from their costly legacy monolithic systems, that is mainframe. And we were able to, modify and help, we were able to help with the customer in their maintenance, performance, and security, with an improvement of ROI to their investments. Last but not the least, on the mission critical microservices, right? We have a customer who is actually a huge, provider of stock tickers and financial data markets globally, right? Now, they are backend for some of the major financial companies, and they have to handle a lot of data in and out, at the low latency, at the cost of low latency. They cannot absolutely, go or run their business. And they replaced Redis and the AWS RDS, with Yugabyte to get both caching and data store in place, right? What they basically do is they provide market data as an API and microservices, and they do a tick by tick or a bid ask data provide to their major financial industries. And major customers for them are large financial houses globally. With the help of database YugabyteDB, right, they were able to reduce the batch write and range queries to less than a little over 10 millisecond, right? They are currently operating at a scale of 10 billion operations per day. They have about a 60 terabyte of data set, and they are handling a little over 200,000 transactions per second at the peak, right? They are multi-AZ, and they have set up a multi-region cluster, and they were able to achieve a lower total cost of ownership and complexity, by replacing Redis and AWS RDS. So these are a few of the documentation and certifications. Now we have a public Slack channel if you're interested in pursuing database to your use cases, you are very welcome to join our open source. We have, Yugabyte University, where if you want to learn more about Yugabyte, you can go into the Yugabyte University, sign up for free, and pick up the database uh, tracks as well. So we have, different tracks for the API layer. We have different tracks for the database administrators, the application developers. So why don't you go and check out the Yugabyte University, and they have a pretty, we have a pretty, great content out there in Yugabyte universities. Every Friday we have a Yugabyte Tech Talks. So you can sign up for Yugabyte Tech Talks. We, our speakers speak about a wide range of databases, not specific to Yugabyte, but then we talk a lot about query optimization, performance tuning, and things like all stuff database out there. Like I mentioned, we have an open source community as well, so you can join, you can ask your questions, you can deep dive into Yugabyte, and you can play around with it. We have DSS, Distributed SQL Summit, happening every year. We have our speakers, videos, and we have a playlist out there, so you can go and check out our Yugabyte database, channel out there in YouTube as well. And yeah, that's pretty much about it. And in the YouTube videos also, we have our best practices on architecture, so you can also skim through the widely used and the best architectures that we are offering to our customers out there. Now let's take a quick look at the demo. So in this demo, what we have is right over here, we have a 3-node cluster, right? This is actually a one zone cluster. There is no, there is no, there is no workload currently running. So what let me do is let me start a couple of workloads, and then we will see how Yugabyte is actually doing a auto failover, and it is helping to maintain your resiliency. So right now we have a read operation going on with a little over 4,000 transactions, and you can see the other parameters as well, with the average latency being around a little over 15 milliseconds. And this is the latency, throughput, and graph. So what I'll do is let me switch off a particular node, right? And then we'll see the how the resiliency is being maintained over here, right? Okay, so what I've done is I have turned off the database node number 2, right? So on this architecture, what you will see is after some time, the database node 2 will go down. We can see that there is no transaction currently going on. And a few seconds later, we'll see that the transaction has again started. So what we see is a little over, 3 second, a little over 3 second for your RPO, which is recovery time object, and within 3 seconds, you're again back into the business. There is no absolutely effect to your user base. It is as simple as your user base never knew that there was an outage that happened, right? And with the help of auto sharding, the other two nodes, what it did was it was able to handle the read queries that we are currently running, right? See, right now you can see there are only 2 zones which are actually running right at the moment. And what we will see is with the help of the Cassandra, with the help of the SQL language, right? You will be able to query the database, right? And okay, let me restart the node, and then we'll start the YSQL, and then we will see the tables, with the help of Cassandra query language, the schemas, that uh, we have right now, the table structures and the schema that we have, that we have started. So just give me one moment. Okay. Okay, so we are in the YSQL SH. Let me list the tables. So these are all the tables that you see right now that we have, that we have loaded on this particular database. Then we see the users. These are all the database users that we have created. Now let us look at the table sizes. These are all few of the table sizes that you have, and let me give you a walkthrough of how the UI looks like. So this is the Yugabyte UI, right? So right now I've hosted this locally on my machine. So I'm using a localhost port 7000. So, this is the UUID that you see. The replication factor is nothing but the number of nodes that you can deploy your Yugabyte database with. You can see the complete Yugabyte, database cluster information from here. Again, let me quickly show you how the tables are, right? So these are all the tables that we have currently loaded: books, generic 1, generic 2, and generic 3. And with the help of UI, you can see the key space, the state of that table, the message, and the UUID of that particular table. And right now you can see the total number of space that the table has, the wall file, the SST tables, and other. If the table has the table has compressed or uncompressed, you can also look at the sizes. The fact that we want to look at is, the table sharding, right? Now I mentioned that the auto sharding is enabled in Yugabyte by default. So with the help of sharding, what you can do is right now you can see that all of these tables are basically sharded into different shards. And the point to take a look at is not one not a particular node will have your shard, right? Each of these shard will be followed by a leader, which will, in case of a complete region going down, what the leader shard would do is leader shard, for example, if the leader shard was residing in an zone which went down, right? So the other nodes, what that would do is, the shard which doesn't have a leader, what they would do is they would quickly allocate a leader between amongst themselves, and the consistency of this database would again be maintained, irrespective if your complete node or a complete data center or a complete region goes down, irrespective of the kind of deployment that you have. That you have deployed. Uh, so with that being said, I think we are at the top of our webinar for this. Um, I think we can devote the next 4 minutes for questions. Leila, do we have any questions on the chat?
Yes, we do, Jagdish. There's one from Mr. Andy Ang. So he's asking, is Yugabyte distributed database used behind Dropbox or kind of Microsoft SharePoint to be used as its engine?
So basically, how Yugabyte, what we have done is we have an open source database which is available in public Git. So what you can do is you can actually repo or clone the database locally on your machine, and you can start using the Yugabyte database for your use cases, or if you just want to play around with Yugabyte.
Thank you, Jagdish. I think that's all the questions we have at the moment. So we'll just leave this open for another 1 to 2 minutes. And if there is no other questions, then we can end the webinar. So in the meantime, I've also posted the our survey form. So please fill up the form if you want to get some awesome swag, win some awesome swag from us. And then you can also use it to book your demo with us.
Okay. I will just present the QR code as well. So, folks, you can also scan this QR code, and you can go to the survey link.
Jagdish, there's another question. So how does Yugabyte compare with CockroachDB?
So we would have to look into what kind of comparisons you're looking at, right? Again, like I mentioned, right, each database has its own pros and each database has its own cons. So in order to answer more specifically, maybe we can look into the use case and we can have a comparison.